Okay, so what we're going to focus on today is square root functions, and we're just going to focus on domain and range and our starting point. I gave you graph paper because we are going to eventually graph them, but we'll probably do that tomorrow. So your homework tonight is just going to be on the domain, the range, and the starting point, so that's what we're going to focus on. Okay? So, what is a square root function? A square root function is a function that contains a square root. So let's start with that. A square root function. That's why our do now had the square roots in it. So a square root function, and you probably recognize this from your vocabulary that we did last quarter. A function that contains a square root. Now, you guys, you can have radical functions. You remember a square root is a radical. This just means that the only root that we're actually looking at is the square root. So, like with any function, there are parent functions. So we're going to talk about our parent function. So we're going to add things. So our parent function is f of x equals the square root of x. That's our parent function. That means that's the most basic function. We graph that, and everything is going to be based off this function. So for the parent function, your domain is x such that x is greater than or equal to 0. So for this function, x equals 0. And I'm going to tell you how to find the domain. Every time you do this, when you solve for that x, we're going to talk about how to solve for the x. The x is always going to be greater than or equal to a number. So this is how it's always going to be. It's never going to be less than. It's always going to be greater than or equal to. Your domain is always going to be this way, but the 0 will change. But for the parent function, it's always 0. Our range is f of x such that f of x is greater than or equal to 0. And you guys remember that f of x means y. Again, you guys, your domain is always going to be greater than or equal to. Your range is always going to be greater than or equal to. It's always going to be that. It's never going to change. You're never going to have to worry about, well, is it less than, is it greater than? It's always going to be greater. It's always going to be greater than or equal to. Now, and this goes for any of them. Well, specifically in this one. In this one, x can't be less than 0. So if we get to another one, so if I ask you where it's not defined, then it would be whatever x is less than. And it's usually whatever the domain is. And so I'll tell you a little bit about that. When we do examples. So your end behavior, oops. So your end behavior is going to be x as it approaches 0. Now, if our number changes, then it would be x approaching that domain number, and f of x approaching the range number. And notice it's always approaching positive infinity, okay? So those are parent functions. So what we're going to do now is we're going to apply them to non-parent functions. Okay, so example 1. So what we're going to focus on in example 1 is we're going to find that domain, that range. We'll talk about where it's not defined, and we're going to talk about the starting point. So f of x, oh, yes, there we go. Sorry about that. F of x equals x plus 3. So this is our problem. Notice it's a little bit different than our parent function that we had written as f of x equals the square root of 3. This is just the square root of x plus 3. So what we have to find out is what x is greater than or equal to. And in order to do this, and this is why we kind of did what we did on the do now, is we're going to set what's underneath the square root. Only what's underneath the square root equal to 0. So we're going to come over here and we're going to put x plus 3 equals 0. And then we're going to solve that. X equals negative 3. Now, it's not that x equals negative 3. What it means is that's our starting point. That's one of our starting points. So it means our domain is x such that x is greater than or equal to negative 3. Okay, so that's our x. So our x is negative 3. So what we're going to do is to find out our range, we're going to plug in negative 3 into the equation. So to find our range, we're going to take the negative 3, and we're going to plug in negative 3 into the equation. So again, once you find your x, you plug it in to get your answer. And so when x is negative 3, what is f of x? What is f of negative 3? Negative 3 plus 3 is 0. What is the square root of 0? So that means my range is f of x, which you guys can't see. So I plugged in negative 3, got 0, and now I'm going to write my range. F of x is f of x such that it is greater than or equal to 0. So there's two things that you can determine from what we just found. The one where the function is not defined. So again, not defined is where you can't graph it, okay? So basically you can't, it's undefined or not defined when x is less than negative 3. So anything less than negative 3, you can't graph the square root function. Now we can find our starting point by using our domain. So what number was x? What did we find out x to be? Negative 3. And what is the domain? I mean, what is the range? The number we got for the range? 0. So we can figure out just from finding the domain and the range, we can find where it's not defined, and we can find the starting point. Okay. Okay, you ready? No, you're not, because I okay. Oh, I know what time it is. let's just find the first thing and then we'll stop and then, okay? So we're going to set it up to x plus 6 equals 0. Just what's underneath the square root, okay? And then x equals negative 6. Okay, so I am giving you homework tonight. I am. Yeah, I am. It's going to be, okay, so x equals negative 6 because I just set what's underneath the radical to 0. So that means my domain is x such that x is greater than or equal to negative 6. How I got that negative 6 is because of this. It's always greater than no matter what. Now, to find my range, what I do is I'm going to take this negative 6 and I'm going to plug it into the equation. So to find the range, I'm going to do f of negative 6 equals the square root, and where I see an x, I'm going to put a negative 6 plus 2. Remember that 2 is on the outside. So this negative 6 plus 6 is 0 plus 2. The square root of 0 is 0. 0 plus 2 is 2. So that means my range is f of x such that f of x is greater than or equal to 2. You guys, again, it's always greater than or equal to. Always. It's never going to change. Now let's talk about my not defined point. Not defined when x is less than negative 6. So if I put in negative 7, I would get a negative number, so it's not defined there. And then my starting point is, what did I get from my range? Negative 6, and this should not be, it should be a parenthesis. I apologize, you guys. And then whatever I got for there. That's my starting point of my function. So the square root function is not defined when x is less than negative 6. You guys, if you get a negative number underneath the square root, it's an imaginary, so it wouldn't be defined. And then our starting point is negative 6, 2. So right now, all I'm worried about is, can you find the domain? Can you find the range? Can you tell me when it's not defined? And can you tell me the starting point? That's what we're going to focus on today. Tomorrow, we're going to focus on that graphing. Okay, so now what we're going to do is we're going to do example 3. Okay, example 3 is going to be f of x equals 4 square roots of x minus 5 plus 3. Okay? Now there's a 4 in front, x minus 5 plus 3, and we're going to look for that domain. Even though there's all those numbers, to find the domain, it always is based with what's underneath the square root. Okay? So it's x minus 5 equals 0. We're going to add 5 to both sides. X equals 5. So my domain is x such that x is greater than or equal to 5. My range, what I'm going to do with my range now is I'm going to take this 5 and I'm going to plug it in. So it's going to be f of 5 equals 4 square roots of 5 minus 5 plus 3. Now you guys, remember, this is 4 times the square root. So the square root of 5 minus 5 is 0 plus 3. Well, the square root of 0 is 0. So this becomes 4 times 0 now. Well, 4 times 0 is 0. 0 plus 3 is 3. So my range is f of x such that f of x is greater than or equal to 3. So again, the first thing you do is you take what's underneath the square root and you set it equal to 0. That's how you find your domain. Then you take the number you got for your domain and you plug it in. And then whatever you get as your answer is your range. Now, so let's talk about where this function is not defined. X cannot be, so the domain is always greater than, not defined is always less than, and it is less than 5. And let's think about this, you guys. What's a number less than 5? Let's just go with 4. 4 minus 5 gives you a negative. Well, we can't take the square root of a negative number, so we get an imaginary, so that's why it's undefined, not defined. So again, remember, look at the difference between the domain and the not defined. Domain and range are always greater than. Now let's talk about that starting point. This is going to be really important when we go to graph tomorrow. So that starting point is going to be 5, 3. Where did I get the 5? I got the 5 from the domain. Where did I get the 3? I got the 3 from the range. And you can't see that. Now you can. So not defined has to deal with the domain, and the starting point deals with the domain and the range. So again, I found the domain, 5. That's my not defined and my range, so it can be greater than or equal to, but notice the defined has to be less than. And then I plug it in. Okay? And then your homework is, the assignment is, and you can go look in the folder that says assignments. I will place these notes not only in the notes folder, but also in the homework. So homework would be page 403, 19 through 28. And I don't want you to graph anything. All I want you to do is find the domain, the range, and the starting point. Thanks, guys, and I hope you're having a great day.